So we have seen that every language mm, for us to build a machine, there must exist a finite description. It can be the language can be a finite subset of sigma star or an infinite subset of sigma star, but it must have a finite description. So a description, again, it is basically a string that is constructed from another alphabet, let's say tau. Okay, so another alphabet set we use to give descriptions. Okay, so how many languages are possible, right? So for a given alphabet set sigma, we can construct a sigma star which is infinite. So this is actually a countable infinite, as we said earlier. But the number, then now what are the number of languages, which is basically number of languages, which is basically number of subsets of sigma star, right? So how many subsets are possible? 2 power size of sigma star. Now there is actually a result that 2 power, like the size of, we call this actually a power set. Okay, power set of A is basically set of all subsets of A. We have 2 power n subsets. All those set of all the subsets we call power set. Okay, so we have another result called something size of power set of A, where A is countable infinite. Then this will become an uncountable infinite, which is strictly greater than countable infinite. Okay, so number of languages possible, which is uncountable infinite. But every language we can only give a finite description using this symbol. So number of language descriptions we can give, it is basically all the strings that we can generate using tau, which is basically tau star. Similar to sigma star, this is actually countable infinite, which is strictly less than this. So what we have is basically number of possible languages is strictly greater than number of possible language descriptions. This implies there exists languages with no finite descriptions. So no machines for those. For solving computational problem for those languages. Right? Let me explain this once again. So number of possible languages is basically number of subsets of sigma star. Sigma star is a countable infinite that makes the power set uncountable infinite size, and number of possible languages is uncountable infinite. And number of language descriptions we can give is basically all the strings that we can generate using tau. Tau is basically another alphabet set we use to generate language descriptions, right? A language description is also a set of finite, a formal manipulation of symbols, right? We said earlier. So all the strings that we can generate using a finite set of symbols, those are basically set tau star, which is a countable infinite, which is strictly less than uncountable infinite. So from that we get to here number of possible languages is strictly greater than number of language descriptions. So that means there exists languages with no possible language descriptions, right? Only some languages get descriptions, which are basically part of either regular languages or context-free grammars or recursive grammars, right? So there exists no machines for those kind of languages, since we can only build machines for languages that are computable and has a finite descriptions. So in this case, number of computable languages actually having a finite description doesn't even imply that it will be computable exactly. So number of computable languages is even less than number of possible language descriptions. So our statement is still true, and of those descriptions, like some multiple descriptions might refer to the same language. So yeah, that supports our statement even stronger. Okay, so this is the optional part. The only takeaway you have to take from this is languages are subsets of sigma star, and not all languages can there exists some languages with no machines. So in that Chomsky hierarchy diagram we saw, this is regular languages, this is context free, this is recursive languages, and these are undecidable in some other languages that we cannot build any machines for. Okay, so this is the end of week 1. Please watch all of these videos and just understand the basics. These are just basic definitions that we will need, all the basic introductions to theory of computation. And from next week I can guarantee we will not have this much theory intensive, mostly problem based things you can follow easily.